Hello everybody, thanks for checking out my video for Unit 1, Day 4. As we get close to wrapping up Unit 1, we're really talking about key features of graphs today. And by key features, I mean from the state standard. Being able to take all the different kind of functions that we'll do so we can see different types of pictures, but being able to pick out and identify the domain and range, which I'm sure you heard of, but also increasing, decreasing zone, positive, negative zone. Now, there's some other words on here that really won't pop up for us until Unit 3. Mainly, we're going to take care of these ones on the left today and some tips. These are not coordinates today. The way we're going to write the answer is think of it as a start to finish. And I'm going to come back and use this page once I do a couple to actually summarize. So in this picture, if I was talking about the increasing zone, that would be the green side. And it starts at 1. We used x values pretty much all the time. And it's increasing all the way to infinity, hence the arrow. So on this first one, the increasing zone would be from 1 to infinity. And at 1, it's not actually increasing, so it didn't get bracket with 1. 1 is not included. It's just 1 is the beginning. We could do things like, and again, that was the increasing zone. We could do things like the negative zone. Negative zone, by definition, is wherever we are under the x-axis. So if I use this second picture, we always work from the left to the right. So I'd first become under at 2. And it will stay under until it gets to 4. Remember, I'm using x values. At 2 and 4, it's not technically negative. It's not technically under at those. So we put parentheses again for not included. And that was the negative zone. But I'll be a little bit more formal as I go through my next couple examples. So I'm going to use examples that I'm not doing in class. So this video will serve as extra practice, like some pretty good extra practice. So remember, think of it as start to finish. Generally, it's left to right. It's always going to be small number, big number, like you just see me doing with a 2 here and a 4 here. Remember, parentheses means it doesn't touch or include, if you want to say it that way. Best to say include. Bracket means it actually touches or includes. And since it's small to big, it can never be infinity in the first spot. It can never be negative infinity in the second spot. So anyways, kind of enough of talking about it. Let's go ahead and jump in and do one. So I think the first one I'm going to end up doing for the video, again, these are not going to pop up in class. Different examples, so a lot of opportunities. So domain definition is just from left to right. How far does the graph go from the left to the right? And this graph has an arrow. It's going to go all the way to negative infinity. Now look at that as left and not down. On the right side, even though it's going down, again, domain being left to right, how far right is it going? This arrow says it's going to infinity. So the domain is going to be negative infinity to infinity. You can also call that all real numbers. I'll start clearing off my screen in just a moment. But range, much like domain, range is a small number to big number, but range is from low to high. And this is the only time we will use y values. Since we're talking about lowest to highest, we're going to need to use y values, not x values. Any other time, use x values. So again, you got these arrows. So how low is it going to go? It's going to go as low as negative infinity. But it does not go up forever. It only goes as high as this point. Now, a lot of kids would say it goes as high as 1, but remember what I was just saying about, we're talking about high and low, not left and right. So we're using y values. So the highest it hits on y is 0. So the lowest point was negative infinity. The highest point is 0. We'll never touch infinity, never include infinity. So that's always going to be parentheses. But we actually do touch 0. So for the first time, you'll see me use bracket. Decreasing zone, we're looking for the side that is going down. Always read from the left to the right. It's going to be drawn like a little car on the left side. We're going to go up, and then we're going to go down. So let's highlight, or in purple is already highlighted, the decreasing zone. I'm sorry, purple is the increasing zone. Green is the decreasing zone. So let's stick to the order. We'll do decreasing first. We first start decreasing as the car climbs the hill right here. Remember, we're talking about left and right again. So at 1, we first begin to go down, and the car will go down apparently via this arrow all the way until it reaches infinity. We can't include infinity. And technically at the very top right there at 1, it's not technically going down. So 1 is not included as a decreasing spot. So neither one of those numbers were included as being decreasing. They're just like the start and finish. Again, I first started a decrease right there at 1. So switch over to purple. Let's do the increasing zone. So boom, my car on the left side is already increasing as soon as it starts. And when it first started to increase, well, you got this arrow. It was increasing forever. It's always been increasing from negative infinity. Remember, left side, negative infinity. Right side, positive infinity. Now, does it go up forever? No. At some point, it's going to stop going up at the same spot that it started going down. It stopped going up at 1. And 1 again is sort of flat. 1 is not increasing or decreasing, so 1 is not technically included as an increaser. Positive zone and negative zone. This is not a very good one for positive zone. Remember, anywhere that we are above the x-axis. In this graph, we never get above the x-axis. So this is undefined for positive zone. Now, negative zone is actually a really good example. Because again, when I start, I'm already in the negative zone. I'm below the x-axis. And I will stay in the negative zone. So negative zone is, of course, below. I'm not putting that in words. Negative zone goes from negative infinity. And it'll stay negative until I get to 1. Now, I know it might look like the whole entire thing is underneath the x-axis, but this little spot in red, or pink that is, it's the only spot that's not technically under. So for just a moment, it was no longer in the negative zone. It starts being in the negative zone again at 1, but not including 1, and it'll stay in the negative zone until it reaches infinity. We're talking about to the right. Remember, you will never have negative infinity at the end of either parentheses. And when you got 2 answers, you got to put this little union symbol. All right, let's try some out of a different picture. So delta type of example, we are doing interval notation specifically. I'll probably mention compound some. If you click on delta explanation, it's going to give you this version, but I'm here to teach interval notation. So in the domain, how far left to right? It goes left forever. You always start on the left, negative infinity. How far right does it go? It goes as far right as 7. And the way they draw the picture, it comes down and sits right on 7. So it includes 7. I would like to see a closed circle right there. So 7 was quote unquote touched, if you want to say that. Range, remember range, lowest to highest. How low does it go? It goes as low as this spot right here. Remember, 7 is not a marker, quote unquote, for left and right, or a low and bad. It's not a marker for low or high. Let me say that. 7 is a marker for left and right instead. We don't want left and right. We want to talk about lowest to highest. So remember, the number that you really, really want to use for this is 0. And again, it touches that spot. How high does it go? You might think it only goes as high as 6, but see that arrow? That arrow means it goes up forever. So it's going up to infinity. Can never touch infinity, can never include infinity. Infinity is always parentheses. Increasing zone, remember, always read from the left to the right. My car starts here, it's going to be decreasing. It never increases in this graph, so it's undefined for increasing. Oops, so I skipped decreasing there. It was decreasing the moment it started. It's got the arrow. It's been decreasing forever. So it's been decreasing forever from negative infinity until it gets to 7. At 7, I would say at 7 it's actually stopped, but 7 is in the decreasing zone. So a little bit kind of debatable of parentheses or bracket. I like to see a closed circle right there to show me it's including that. But I think the way they kind of, again, they bring it over there and they set it down like directly on 7, not like 6.999. Positive zone, everything here is positive zone. Positive zone is anywhere we're above the x-axis. This whole entire thing, except for one little spot that is above the x-axis. So, good one to do for positive zone. From negative infinity, when we first started, it was already positive back here. It continues to be positive until we get to 7, but at 7, it is sitting on the x-axis. It's not above the x-axis. So 7 is, think about it, is 7 included as above or 7 not included as above? And it's definitely not included as above. 7 is on. And we have no negative zone at all. We're never negative, so negative zone is undefined as well. So let me talk just a moment about compound inequality. It's a different way of writing these answers. Again, Delta will show you this explanation. Hopefully I can turn that off, because I think I figured out. So we could be any spot in here. Let's call it x. X is anywhere between negative infinity and 7. So the compound inequality version is negative infinity is less than x, and x, meanwhile, is less than or potentially equal to 7. So again, x is somewhere between, note that x is somewhere between negative infinity and 7. It can actually be on 7, so I put the equal sign, or less than or equals. The equal sign is with the less than sign. So that's the explanation they're looking for. But again, here in Math 3, our goal is to learn this version. There's no mention of this on the Unit 1 test. Let's do range. So again, it's always basically the same numbers, but it's just inequalities instead. So my range goes as low as 0. Our x again is in between 0 and so it goes as high this time as infinity. Our lowest point on the range, I didn't do a good job of explaining that in the last few seconds, so I'm gonna fix that now. Range is from low to high. The lowest point is 0. The highest point is infinity. It's going up forever. We're not talking left and right. We're talking about lowest to highest. At 0, we do potentially touch 0. X could be anywhere on this line, including 0. But we can't touch infinity, so it's just less than infinity. Alright, about 90 seconds left potentially in my video. Let me see if I can get in one more little set of examples, so I'm going to go kind of fast here. Let's pretend that the picture being cut off there, let's pretend those are arrows. So domain, it goes left forever and right forever. It's from negative infinity to infinity. You can also call that all real numbers. Remember, range, lowest to highest. The lowest it goes, negative infinity. The highest it goes, infinity. Increasing zone, we have 2 of them. We're increasing from negative infinity until about -1 right there. But you might notice we will start again when we got to put the little u. We'll start increasing again from 1 till infinity. Now, at 1, it was not increasing or decreasing. It was just flat. Same with that -1 right there. Decreasing zone right in here from -1 to 1. It's decreasing. Positive zone on delta is also written as like wherever we're greater than 0. We're positive from -2 right here until we get to 1. We are not positive at those spots. We were negative zone from negative infinity to negative 2. And that's it for negative zone. I appreciate y'all watching.